right, we are live. Give everybody a couple minutes to jump in. We had a little bit of trouble trying to get the streaming software started, but looks like we're going now. So give everybody a couple minutes to jump in. And Caesar's here already. Hey Caesar, how's it going? How was your spring break? So again, we'll give everybody a couple minutes to get started. I had some issues with the streaming software, so might take a minute or two for everybody to catch up here. Sarah's here. What's up, Sarah? How was your spring break? What'd you do? Cleaning? It sounds like my spring break. My wife had a bunch of things for me to do. It was not fun. Um, haven't left the house really like the whole last week. We've been extra careful. We ordered groceries, um, so I'm going a little stir crazy for sure. I think we all are. Um, but so far, it's been okay, I guess, considering what's going on in other states. Certainly could be worse. Um, so hopefully you guys are all being safe and nobody in your family's got sick. Um, the whole situation absolutely stinks. Why is everybody cleaning right now? You should be like playing video games, right? I took a little bit of time. I'm going to be honest here. I took a little bit of time and maybe played Fallout. Fallout is an awesome game. It's very applicable to what's going on right now. It's a post-apocalyptic game, and you have to survive in the wasteland that's the world. So, kind of parallels a little bit what's going on in the world right now, or what could happen if this was a lot worse. So, anyway, I guess I could talk about the Rosetta at home while we're waiting for other people to jump in. I don't know how many people are going to show up. It's the day after spring break, so I don't know how many people will actually show up, but I'll still go through everything for those of you that are here. We are going to be testing Wednesday, but I'll talk about that in a little bit. So I don't know how you guys are. It's super frustrating for me that all of this stuff's going on with the coronavirus, and I feel kind of helpless because there's not much that we can do to help. We're all kind of stretched thin financially, trying to make ends meet. Like my wife's not working right now. I'm the only one working. And it's put a lot of strain on us. So we don't really have financial resources to go out and, throw tons of money at the problem and help people. But I did find a small way that we can all kind of help with the situation. And there's a program that you can run in the background on your computer called Rosetta at Home. Here's a screenshot of what it looks like. It just kind of runs in the background on your computer. And basically what it does is it uses your computer in this huge network of supercomputers, and it's called the Distributed Computing Project. So right now they're taking all of these chunks of data for the coronavirus and they're sending them out to computers, people's computers all around the world, and your computer will analyze a small chunk of that. So it's kind of like having a supercomputer do the work, but it's basically using everybody's computer at home to do the work of a supercomputer, if that makes any sense. So as you can see right here, I have a work unit that my computer was working on this morning for the coronavirus. So if you just Google Rosetta at Home, you can get this program and install it on your computer, and it just runs in the background. You can set it up to run all the time, or you can set it up to just run when you're not using your computer. So it's a really cool idea. It was the platform that it runs on came out of Berkeley, out in California. So it's a really cool concept, and they're doing it's a small thing that you can do to kind of help with what's going on in the world. So it will not run on your school computer, But if you have another computer at home that you're not using, if you install this on it and just let it run in the background, it will download those work units and it will work on analyzing things to try to find a cure. So that's one small thing that you could be doing right now. All right, so this is Virtual Spirit Week. You guys probably got the email. So today is Superhero Day. I sent a shout out on Twitter to all of the teachers and, of course, to you guys as well that are making e-learning happen. You have no idea how much is going on in the background to try to keep the momentum going that we had with the school year. So that's my superhero. But there's a lot of other people out there that we can thank right now. You know, you've got first responders and even the people at the grocery store risking their lives, like literally risking their lives to stock the shelves so that we can have food to eat. So there's a lot of people out there to thank. Tomorrow is Crazy Hair Day. Not really sure what I'm going to do for Crazy Hair Day. Yeah, so you guys should have gotten the schedule. I'm going to be participating every day. Thursday's a cool day. It's a TikTok challenge day. So feel free to tag me if you guys have a video that you want me to do. I'm not on TikTok, but if you search, you can, I don't know if there's a way you can send me the link to the video or tag me on Twitter, and I'm absolutely I will do my best to try to replicate whatever dance you've got on there. So please feel free to do that. All right, so let's talk about the exam. So we do have an exam this week. It's going to be a Google Forms exam, not the Safe Exam Browser. I met with all the physics teachers over the last week or so, and we try to come up with an idea of how we could still have you guys take the test. So obviously, with it being a Google Forms quiz, it's going to allow you to go through and look at your notes on OneNote. You can, I mean, if you really wanted to, you could look things up, but you know, everything should be in your notes. I'm going to open the exam up on Wednesday, so you can go through the exam at your leisure. You can do it Wednesday, you can do it Thursday. It just needs to be done by the end of the day on Friday. The whole test is multiple choice, and here's the cool thing. If you bomb the test, you can retake it as many times as you want until you get a good score. So there's no reason why everybody shouldn't get an A on this test, okay? I did put together a review guide with one of the other physics teachers. So I sent out the first part of it today, and we'll go through that now. And then both today, tomorrow, and then probably Wednesday as well, I'll be doing review during my live stream time, okay? So that's pretty much the plan for today. So I'm going to go through the review guide. You guys are welcome to follow along with me. If you want to just listen to me while you're doing stuff, while you're cleaning, I'll go ahead and I'll go through this. If you guys have questions that pop up as I'm doing this, feel free. But that's the plan here. So our first question here, first part of the review guide asks us to fill in this table. This is the stuff we did at the beginning of the unit. So we were looking at electrons, protons, and neutrons. So this should be in your notes, but the electron has a charge of -1. The proton has a charge of +1. Proton's kind of easy to remember because it starts with the letter P, and so does positive. Neutrons are neutral. All right. As far as mass goes, remember the electron is so small that its mass is insignificant. So for all intents and purposes, we say, hey, Denasia, we say the electron has a mass of 0. The proton and the neutron both have a mass of 1. Okay. The location of the electron is the electron cloud. So electron cloud. Both the proton and the neutron are located in the nucleus. Nucleus. Try to say that 3 times fast. Nucleus. All right. Down here for number 2, it says fill in the blanks to complete the statements. Okay, so a negatively charged object, this is kind of confusing, but a negatively charged object means it has more electrons than protons. Okay, so if it's negatively charged, that means it has more of a negative charge than a positive charge. So it has more electrons than protons. Okay, positively object on the flip side has fewer electrons than protons. So that means it has more protons than electrons. Okay, an electrically neutral object has the same number of electrons and protons. Okay, I'm going too fast, or if you have questions as I'm going through this, please feel free to stop me. But hopefully this isn't from too long ago, so you remember. All right, down at the bottom. Like charges, think about a magnet. If you have two positive ends and you bring it close together, those two positive ends try to repel. So like charges repel. Opposite charges attract. Just like they say in dating, opposites attract. A neutral object and a charged object. This one was kind of confusing. So if you think about the example that I did in class, I had a balloon and I rubbed it against, not my hair because I don't have any hair, but I rubbed it against a piece of fur or carpet, I think it was, and then I stuck it to the wall, which was a neutral object, and the balloon stuck. So these do attract. So a charged object and a neutral object will attract, and then two neutral objects will not interact. So like if I had two pieces of paper, these are both neutral. If I bring them together, nothing happens. All right. What must happen for an object to become negatively charged? So remember, when it's got a negative charge, it has more electrons than protons. So in order for it to become negatively charged, it needs to pick up more electrons. Remember, you can't lose protons or neutrons. You can really only gain or lose electrons. So for it to become negatively charged, you need to pick up more electrons. Okay, to become positively charged, remember you have more protons than electrons. You can't gain or lose protons, but you can definitely lose electrons. Okay, and that's basically it for atomic structure. The next thing we kind of talked about were electric field lines. So for electric field lines, when you have a negative, the field lines always point towards the negative. So it leaves the positive and goes toward the negative. So electric field lines point away from the positive and towards the negative. All right, down here at the bottom, I have two diagrams. For A, we're going to basically, you can do this a couple different ways. I think in class I told you to draw like 4 lines out of each one of them, like this. And then it's going to be leaving the positive and going into the negative. And then you're just connecting the dots from here. Or not connecting the dots, but connecting the field lines. You could bring the back one all the way around, kind of like this if you wanted to, but it's probably cleaner if you just do it this way. All right, for the second one, we'll do it the same way. I'll start with my lines. So for the negative, remember the field lines are going into each charge. All right. Now for the negative, remember the same charges, they repel. So these are going to go away from each other. Like that. You guys are all going to get an A on this test. All right, Coulombs Law. Coulombs Law is where we dealt with the charges. And we had this formula right here for Coulombs Law. So the hardest part about Coulombs Law is probably doing, like if you're tripling or quadrupling or all that kind of stuff. So it says, the first one says, if you increase the charge by 3 times, the electrostatic force blank. So for this one here, let me get my highlighter out. See if I can make this a little bigger. There we go. Okay, so in my equation here, it's talking about the charge. Charge is Q. Why they couldn't label it a C, I don't know. They like to make things confusing. So we're looking at the Q and we're looking at the force, which is, they're both in the numerator. Because remember, this is kind of like being over 1. So as long as you're not looking at anything in the denominator, this is going to be a direct relationship. So As this one increases, this one's going to increase. Okay, so if I triple the charge, if I increase the charge by 3 times, this is going to increase. And another way to think of this is like if I put a 3, if I multiply the right side by 3, I have to multiply the left side by 3. So this is going to increase by 3 times. The second part says if you decrease the charge by 4 times, the electrostatic force blank. So decreasing it by 4, obviously with this being a direct relationship, this is going to decrease the force. And whatever you do to one side, you have to do to the other. So if you decrease it by 4 on the right, you're going to have to decrease it by 4 on the left. Okay. Next, it's talking about distance and force. So we're looking at distance and force. Now here's where it gets tricky, okay? Because distance is in the denominator. So this is an indirect relationship, all right? So it's saying if you increase the distance by 2 times, the force blank. So if I were to write 2d, 2's in the denominator, and I'm squaring it, okay? So 2 squared is 4, but it's in the denominator. So anytime something's in the denominator, when we're talking about the force, we multiply by the reciprocal. So for this one here, you are going to, hold on one second, maybe I'm backwards. Force decreases, oh, I'm sorry, never mind. I was thinking of fractions, never mind. So for this one, the distance is going to be 4, or the distance is 2, but when we square it, it becomes 4. So whatever I do to one side, I have to do to the other. So the 4 is in the denominator on the right side. So the 4 is going to be in the denominator on the left side. So this is going to decrease by 4 times, okay? If I had a fraction, so like let's say I did 1/4 of the distance, which you're not going to see on the test, then you have to multiply by the reciprocal, but we're going to probably keep things easy since this is a Google Forms quiz, and obviously things are kind of a little chaotic right now, so keep that in mind. All right, for the next one, it says if you decrease the distance between the object by 3 times, the force blank. Now remember, as you get closer, as these objects get closer, these charged objects get closer, the force increases, okay, like magnets. If you have 2 magnets, all right, so I've got 2 magnets here. They're not really magnets, they're pens, but as I bring these objects closer together, that force increases between these. So you can feel the pull between the magnets as you get closer. Way out here, you don't really feel that force. But when you get closer, you feel the magnets want to go together. So if you decrease the distance, the force is going to increase. And remember, the distance is being squared in the denominator. So if the distance is being decreased by 3 times, we're going to square that. So this is actually going to be times 9. So we'll increase the force by 9 times. Okay. So we have to fill in this table next. It says fill in the correct symbol and units in the table. All right, so we're looking at our equation right here to fill in the table. So the distance, the symbol for distance is going to be d. D is in distance. The electrostatic force is F, or in this case, F little e. The charge, remember, is Q. It's a little confusing because the units of charge are coulombs, but the letter in the formula is Q. So the charge of object 1 is going to be Q1. The charge of object 2 is going to be Q2. And then the only letter we haven't talked about is the electrostatic constant, which is K. That's this right here, the 9 times 10 to the 9th. Okay, units. The units for distance are meters. The units for force are newtons. The units for both charges, both charge 1 and charge 2, are going to be coulombs, which is C. And then the electrostatic constant, the units are terrible. Okay, I will give you the units if this is on the test. But the units for the electrostatic constant are Newton times meters squared over coulombs squared. Again, I'll give you that if it's on the test, but you don't need it. Okay, so we have two practice problems, and these are like plug and chug type problems. I know you guys get angry every time I say that, but I'm going to keep saying it. Nobody's here to yell at me right now. Okay, it says a negative charge of -4 times 10 to the -6 coulombs and a positive charge of 7 times 10 to the -6 coulombs are separated by 0.25 meters. What is the electrostatic force between them? Is this attractive or repulsive? Okay, this question is reasonable. You definitely might see something like this on the test. So let's go through how to do this. You need to basically just go through the question and plug into the formula. So it's asking for the electrostatic force. So we're going to just use the normal equation right up here. And I'll give you all the variations of it. So like if you look in the second one, it's talking about how far apart, that's the distance. I forgot to give you the formula on here, but on the test I'll give you all the variations of that formula. Okay. So what is the electrostatic force? So we've got our equation. Okay, so K, the electrostatic constant, is always 9 times 10 to the 9th. Q1 is right here, and then Q2 is right here. It doesn't matter which one's Q1 and which one's Q2. You can flip them. It doesn't matter. Okay, so make sure you include the signs. So -4 times 10 to the -6, and then 7 times 10 to the -6. As I told you before when we were doing these, don't worry about the units when you set this up. It can be really confusing if you throw all the units in there. So just leave the units out. Just know that if it's asking you to find force, the units are going to be newtons on your final answer. Okay, the distance is given right here as 0.25. All right, so the way I would recommend doing this, because you guys don't get to use the cool blue calculators, because those are all at the school. So you've probably got your phone instead. So what I would recommend doing on your phone, if you're using your phone as the calculator, same way we did it before, I would make sure that you're using parentheses on your calculator. If you have an iPhone, if you take your phone and you flip it sideways, you'll see that there is a parentheses option here in the upper right hand corner. Okay, so it's a little trickier to do with your phone. There is another way you can do it. Let me show you. There's a couple ways you can do it. So if you go to Desmos, if you've ever used Desmos before, maybe in your math class, the calculator that's in here, I believe, will do it. So if I type it in with parentheses, 9 times 10, 9 times 10 to the, you have to use the little caret symbol on your keyboard. 9 times 10 to the 9th, close my parentheses, and then -4 times 10 to the -6th, and then 7 times 10 to the -6th. And you can see on here, it's giving me the answer right here. So it might be a little bit easier to use something like Desmos instead of your phone calculator, because as you're doing the steps on your phone, it doesn't give you the answer in between. So I would recommend looking at Desmos. Here on the calculator, you could also add extra parentheses. And so that's the whole top in parentheses, and then divide it by the bottom. So you can see it turned it into a fraction, 0.25 squared. So it gives you the answer just like that. That works too. That's a little bit easier than trying to entering it on your calculator, so I would definitely look at that as an option. So the answer was, pull one note back up. So the answer here was -4.03 newtons. Okay, and just looking at the time, it looks like we have a couple minutes left. So if you guys are here early for chemistry, I might run over by a minute or two. Just I want to get through this last problem. The physics students have a test not tomorrow, sorry, didn't mean to scare you. Physics students have a test on Wednesday, so let me get through this last problem and then we'll jump into chemistry. Okay, so for the second problem, it says a negative charge of 3 times 10 to the negative 6th coulombs and a negative charge of negative 5 times 10 to the negative 6 coulombs are pushed apart by a force of 0.75 newtons. How far apart are these two charges? Okay, so I forgot to give you the formula on here, but the formula for distance is the square root of K, Q1, Q2 over the force. Probably have this in your notes somewhere. I don't know why it's not catching up here. Hello. That's fantastic. My OneNote appears, gotta love OneNote, right? Let's try this again, sync. You know what it is? It's probably my son who is killing all of our bandwidth right now playing Fortnite. That's definitely it. Everything is awesome. Everything is cool when you're part of a team. It's frozen. It's fantastic. Okay, well, let me try this one more time. K, Q1, Q2. Don't know why this isn't updating. This is great. It's like the worst day ever because my OneNote's not working. I totally feel you guys when you have OneNote problems. I am hardwired here. I don't know why this isn't catching up here. I have to do it on my, I have a tablet computer. I do it on my tablet computer. There it goes, and it updates. Okay, so let's go ahead and plug in what we've got. So in the question, here are two charges. There we go. There are the two charges, and then there is the force. Okay, so I'm going to kind of finish this kind of quick because I'm a little behind here. But we've got our square root. K is always 9 times 10 to the 9th. Q1 is negative 3 times 10 to the negative 6th. And then the other Q is negative 5 times 10 to the negative 6th. And then the force given in the question is 0.75 newtons. Okay, don't have to square anything. The tricky part here is the square root. So again, you can use the calculator on your phone. I would recommend trying something like Desmos. All right, so that's just desmos.com, and I think it's /calculator. So let me show you how to enter it if you're using Desmos. So I'm just going to clear out the one I just did. So I'm going to enter just the top part before the square root. Let me move this out of the way. Let me see if I can make this bigger for you guys. There we go. Okay, so I'm going to enter just the top part. So 9 times 10 to the 9th. All right, and then negative 3 times 10 to the negative 6th. And then negative 5 times 10 to the negative 6th. Oops. Okay, so that's just the top. Let's see if I can go back just a little bit. Okay, so that's just the top part. Now when we did this on our calculators, I had you store it when we were doing it at school. But what we're going to do here instead is I'm going to do another set of parentheses. So it'll kind of do the whole thing like a fraction, or it should when I do the division symbol. Right, and then 0.75. Now we still have to do a square root. So let's see, I think you do SQRT. Look at that. Okay, let me show you what I did because that was kind of fast. So I typed in SQRT, so square root, and it turns it into a square root symbol. And then I think if you just highlight everything that you had, except for the square root, you press Control X, which is cut. You can paste it into here. The other way you can do this, if that was too much, is you could just do it the way kind of like we did in class, where you did the top. You did the top first, divided it by the bottom, and then took the square root of the answer. That works too. Okay, that's a little tricky. I will double check, but I don't think there's anything Okay, remember, we're trying to keep things easy for you. So I would just know how to do like the basic one with Desmos. Okay, so if you need help with that, let me know. Um, but or if you're good with your phone, use your phone. All right, where do we leave off? So tomorrow is Crazy Hair Day. Yep, tomorrow's Crazy Hair Day. So if you guys do something crazy with your hair, be sure to post a selfie on Twitter and tag me at Zorn Science so I can see your awesome hairdo. Um, if you didn't watch the video for today, the other thing that I'm doing, let me just show you this really quick, and this will kind of lead into those of you that are here for chemistry. Um, when we were actually at the school, I was able to stay after school for those of you that needed help, or for those of you that were coming in early for help. I was there, but we can't really do that right now. So I was trying to think of a creative way where I could still help those of you that needed one-on-one help. So what I did is, and there's a link to this in today's post, there's a book appointment thing that you can click on. But here is a page that I create, a service that I set up, and basically you click on tutoring and then you'll see all of these available appointments right here. So from 9 a.m. every day until 11 a.m. every day, I have 4 appointments. They're 20-minute appointments where you can basically, you get me all to yourself, and I'll send you a link that you click on, and it'll open. I'm going to try Zoom first. It's like kind of like Skype or FaceTime, but it's got some other cool features. I can see your screen if you want me to. You can see my screen. So if you're not understanding something and you feel like you need one-on-one help, like the live stream's not helping, you can certainly book an appointment with me, and it's just going to be you and me, and we'll go through stuff. So if you're in the physics class and you feel like you need a little bit of extra help, you can certainly take advantage of that. It's there for you guys, okay? Nothing would make me happier than to hide from my family and help you guys with school. So just, you know, you're doing me a favor if you do it. Don't feel like you're a bother at all, okay? So with that, I'm going to pivot to chemistry at this point. I apologize for running a little bit over. So for all of you that are here for chemistry, I'm going to repeat this again. That's my dog. I don't know if you guys heard that. I'm super frustrated that there's really not much I can do with the current situation we're in with the coronavirus. But there's a project out there through Berkeley, which is a university in California. They put this platform together. It's called distributed computing. Now just bear with me for a second because it's kind of a cool idea. So rather than having one supercomputer in their building, basically what they do is they take big computing projects like trying to crunch the cure for the coronavirus, and they chunk it into small units, and they send out those units to other people's computers to analyze. So it's kind of like using everybody's computer that's a part of this project and networking them together into one big supercomputer. So they have taken a lot of the data that needs to be analyzed to find a cure for the coronavirus, and they put it into this platform. Now, it's not really that difficult to sign up for it. If you just Google Rosetta at home, you can find the webpage that kind of walks you through how to put it on your computer. But basically, this program just runs in the background on your computer, and it will download the data, and it will analyze it. So here's what it looks like on my computer. This is from this morning. It doesn't look, I mean, honestly, once you get it installed, you can just leave it. It does its own thing. But if you want to look at it, it'll actually tell you what it's doing. So on mine here, you can see that it was this morning, it was working on a data unit for the coronavirus. So this is a small part that you can play to actually helping to find a cure, so you don't feel like you're just kind of at home doing nothing. You know, that's kind of where I'm at right now. I'm kind of frustrated that there's not more I can be doing. So this is a small part we can all play to help find a cure. When the project, another part of the Rosetta at Home project is it also helps crunch simulations for other projects that are important in the medical field, like trying to find a cure for cancer. So when this is all over, if you leave it on your computer, it's definitely a worthwhile cause. So just wanted to share that with you. So let's talk about the Calorimetry Lab. That first week of e-learning was rough for all of us, not just you guys, but for me as well. So, oh my God, that dog is being so loud. Really wants to learn chemistry, I think. I don't know if you guys can hear the dog barking or not. Might have to go out there in a second. Stupid dog. Okay, anyway, that first week of e-learning I know was really difficult for all of us. So I looked over the weekend, and most of you hadn't done anything with the summative lab. Denasia, I don't know if you're still in the chat or not, but you were one of the few people that actually did it, so I'm super proud of you for that. But for everybody else, I get that it was kind of a crazy week. We were trying to sort things out on our end, and you guys were trying to figure out what to do. I'm sure you had other things going on. Whatever the reason, it just didn't get done. So what I'm going to do is I'm going to push the deadline. I'm not going to even look at it until the 15th. I won't grade anything. So you have until the 15th if you want to do it. It is going to be a summative grade when it goes in, so it'll help your grade a lot. If you do need one-on-one help, the thing that I was talking about, that tutoring platform. So if you go in and you click on that book appointment link, you can just make yourself an appointment for some one-on-one help, and I can go through, I can look at what you've got, I can answer any one-on-one questions you have, and we can go through and we can finish the lab. All right, so you have until the 15th if you want to get it done. If you need help, reach out to me, but that's basically it. So let's talk about the material for today. You didn't watch the video, I'm just going to give a quick recap, and then we'll do a practice problem. So we were talking about the 3 states of matter. This animation's awesome, isn't it? So we have 3 different states of matter. We've got solid, so think about water. You've got solid ice water. You've got liquid, which is what you drink, and then you have like a gas form of water, which could be like water vapor in your shower. So we've got 3 states of matter. You've probably heard of them before. I'm sure you covered them in like middle school or something. So we talked about that, and then when we transition between the various states, we've got some words that you've probably heard of before. So when we go from like an ice cube to water, we say that it's melting. I've heard that word before. And then when we go from a liquid to a gas, so think about how do we get our water on our stove to turn into like a gas vapor? We heat it up, and we get what's called boiling or evaporating. So that's how we go from a liquid to a gas. So this is when we are adding heat energy. We'll go the other way when we remove heat energy. We're going to start with the gas phase. So we've got like water vapor, and we're trying to turn it into a solid. I don't think I've ever actually seen this happen in like nature, but I'm sure that I've seen it maybe in a lab experiment. But when we go from gas to liquid, you've probably seen like dew on your grass in the morning in the summertime. That's condensing or condensation. And then when we go from a liquid to a solid, it's just freezing. Like, you know, think of water. You stick it in the freezer and it becomes a solid. That's just freezing things, okay? So you're probably familiar with those terms. And then the next part of the lesson for today was taking these different phase changes and graphing them. So this is a heating curve. The Celsius scale, remember, is awesome because water freezes at 0 degrees Celsius. On the Fahrenheit scale, it's what, 32 degrees Fahrenheit? Just some weird number. And then water boils on the Celsius scale at 100 degrees Celsius. On the Fahrenheit scale, I think it's like 212 degrees Fahrenheit at sea level or something weird. Yeah, so it's always going to be 0 for freezing and 100 for boiling. So on a heating curve, we are going to start in our solid state, which is the lowest amount of energy. And basically, as we start to add more heat, we creep up on this graph. And then once we hit a plateau on the graph is that flat area. Once we hit a plateau, we're changing states. So when we go from solid to liquid, or we go from liquid to solid, we end up with a plateau right here. Okay. Diagonals on the graph are changes in temperature. So once we turn into a liquid, if you look on the graph here, our temperature continues to rise. So as we get closer to 100, our graph, I guess we're creeping up the graph closer towards 100, but once we hit 100 degrees on the Celsius scale, we plateau again. So all of our liquid water is now turning into a gas vapor. Once it's all been converted to gas, we start to raise the temperature of that gas. Okay, so it's a little confusing because there are these plateaus on the graph. Okay, if you think about it, you're increasing the temperature. You'd expect your graph to look something like this, just one straight line. But we have these plateaus on the graph because at that point, it's changing everything over. So it's going from a solid to a liquid or from a liquid to a gas. All right. and I had a practice problem that I wanted to work through with you guys. So for today, all you had to do was that Google Forms quiz over the material. Try to keep it simple and short for you guys. But I wanted to go through one of the practice problems in OneNote. You didn't have to do this, but this is just extra practice. Denasia has a question. Fire away. Why are you crying? I'll give you a second to type your question in the chat. I don't know why my chat for some reason is not showing up on my stream on YouTube. I don't see a Google Forms quiz. Okay, so if you go to the post for today, oops, not that. All right, if you go to my website and then you go to the post for today, you can get to it by clicking on eLearning and then chemistry. So here is today's post. So the video, me going through the instructions, and then if you look down here, down in the reading here, it says, you know, there's the screencast button to click on, there's the guided notes, and then if you click on the link here for the short quiz, it should pop up for you, okay? So it's short. You can knock it out in like 5 minutes. It's a lot easier than going through and writing out written practice problems. Did you find it? I don't know why my chat isn't showing up here. Oops. Okay, you got it. Something's weird. My chat is not showing up on my stream, but I'll fix that later. All right, so I gave you this practice. This is in your OneNote if you want to follow along as I do it, or you can just watch me do it. But basically, we have a heating and well, is this a heating or a cooling curve? That's a good question. So if you look at the graph here, let me pull this up on my tablet so I can do this with you. All right, so if you're looking at the graph is starting at this point right here. And if you look on the y-axis, I know it's a little blurry. Is it going to do this to me again? I had this problem earlier with physics. It wasn't updating. My son is playing video games upstairs and he is sucking up all the bandwidth in our house. Let me restart OneNote here. Google needs to get their act together and they need to get handwriting on Google Classroom because I'm getting pretty sick of OneNote. Only reason I don't use Google Classroom is because it doesn't have handwriting input. Frustrate me if this doesn't sync up. Now I know why you guys don't like this. I am online and it's saying I'm not online. Wow, how does that happen? How does that happen? Let me try doing this. Sync now. If this doesn't work, I'll just do it with my mouse on the other computer. I have two computers doing this. I have my tablet and then I have, still not doing it. What is going on here? Okay, I'll just do it this way. See, look at this. I'm obviously connected to the internet because I'm live streaming right now, but it says you don't appear to be connected to the internet. Okay, we'll make do. So we have a graph here, and my question was, is this a heating or a cooling curve? And if you look on the y-axis at this point right here, you can see it's a little blurry, but you can see that we're between 80 and 90 degrees Celsius, okay? And then if I follow the graph down here, F ends around 0 degrees Celsius. So we're starting at a high temperature and we're ending at a low temperature. So if you start high and you end up low, it's going to be a cooling curve. If it was flipped and we were starting at like 0 and creeping up towards 85, that would be a heating curve. But this is a cooling curve because we're starting high and we're cooling down to a lower temperature. Okay, and I apologize, I'm going to have to do this with my mouse instead of my pen, so It might be not super legible, but I'm going to do my best. So down at the bottom here, it says label the following sections of the graph: solid, liquid, and gas. Okay. So because this is a cooling curve, we're going to start where we have the most energy, which is the gas phase. So up here, maybe I can type this so it's a little more legible. So this is going to be, this is frustrating me beyond belief today. Okay, maybe I'll have to write it with the mouse. Okay, so this is going to be the gas phase right here. Remember, anytime you're on a diagonal, the temperature is changing, but your phase isn't changing. All right, so our gas is starting to lower temperature. All right, plateau is when we change phases. So when we're going from a gas to a liquid. Right. So from here, this is the next diagonal. So this is where we are in our liquid phase. And then plateau, we're changing from liquid to solid. Just like that. All right. It says to label where we're 50% solid and 50% liquid. Okay, so any of those plateaus on the graph is considered a phase change. So this point right here, try to make this a little bigger. This point right here, we are, I can't write this all out. So this is going to be, we'll call this half, we'll just call that the halfway point. So that's half gas, half liquid at that point. All right, and then on this other plateau down here, this is going to be half liquid, half solid. Okay, so this whole part right here, we're in the gas phase. This whole part right here, we're in the liquid phase. This whole part right here, we're in the solid phase. Those plateaus are kind of in between, so things are getting changed over. All right. So the other part it wants us to label down here is when freezing is complete and you're 100% solid. Okay, so right here at point E is when we are done freezing. So if you're kind of following the graph, as time goes by, you notice the temperature is dropping here. So at this point right here on the graph, at point E, we are totally done changing all of the liquid over to solid and we're done freezing. Okay, freezing begins and we're 100% liquid. Okay, so here again, this is what, point C. At point C, as we're following the graph down, so we are gas, the temperature's dropping. Here we start to change from gas to liquid. And at this point right here, we've changed everything over to a liquid. Okay, and then here we would go down from, our temperature would continue to drop as a liquid. Okay, condensing complete, 100% liquid. So on the graph, we can go both ways. We can either freeze or we can, the freezing point and the melting point are the same point here. I'm just trying to read the directions here. Oh, I see. Okay, so we're going the other way. Did this all this morning. I've actually already gotten everything done for tomorrow already, so I'm like one step ahead mentally than this is here. Okay, so when we're going the other way, so hold on, let me back up just a second here. Okay, so freezing's complete, you're 100% solid. So at point E, I was right, yeah, so for point E, you're 100% solid. And then you're 100% liquid at point D. I don't know if that's what I had before. Freezing begins 100% liquid. Yeah, okay, so you're 100% liquid here. The way I know is because when we are going from solid to liquid, this point right here, you notice we're going from a solid to a liquid. So we're 100% liquid here. Down here, point C, we are 100% liquid. This is the other point where we're 100% liquid. All right, and then gas, this would be point B. Zorn, Cecilia's jumping in here. I am so proud of you for jumping in. I have to talk to you about things, about life. We have to sit down. We have to have a conversation. Okay. Anyway, so on the graph, just know that the plateau is a transition state. So when we're going between the various states. So let me kind of clear this out one more time. I think the way it's worded on here is a little confusing. So let me just try to clear this up one more time because I feel like I may have confused a couple people with that last part. So let me back up just a second. All right, so if you look on the graph, I'll talk to you in just a second, Cecilia. I've really missed talking to you. You know, when you would come in for advisory, I feel like we had a lot of really good conversations, and I've missed out on those. Okay, I've had to talk to my cat instead, and my cat doesn't talk back. There's no witty retort for my cat. Anyway, so if you're looking on the graph here, all the points in yellow are where we're either gas, liquid, or solid. Okay, the diagonals are temperature changes. All of the blue parts on the graph here are phase changes. So that's when we go from gas to liquid. So we start as a gas, there's a liquid, and then that is a solid. All right. So this point right here, point B, is where we are starting to go from gas to liquid. At point C, we have gone, all of our gas has turned into liquid. Point D on the graph, if you look here, we're starting to turn our liquid into a solid. And then point E, we've turned all of our liquid into a solid. All right? So, I don't know if that helps or not. Just know that plateaus are phase changes. Plateau starts with the letter P. Phase starts with the letter P. And then the diagonals on the graph are where we have a temperature change. Okay? All right. So there were some other questions here. It says, let me see if I can make this a little smaller so I can see everything at once, or you can see everything at once. All right, it says determine what in the world are you teaching? I'm going to be honest, I don't even know. I'm just one day ahead of you guys. I'm just kidding. Cecilia, I will email you when I'm all done because I definitely need to, you and I need to talk. All right. So is this a heating or cooling curve? We've already addressed this. This is a cooling curve because we're starting at a higher temperature and our temperature is decreasing. So this is a cooling curve. Cooling curves are always going to be exothermic, okay, because you're releasing that energy. You have all of this heat energy when you're at 85 degrees and it's getting released as you go down. And it says, how do you know? So I just kind of gave you the reasoning right there. So it's exothermic because the heat energy is being released. The temperature is going down. All right. What is the melting temperature? Don't worry, you're not in trouble. It's actually something really good. So after we're done, I'll shoot you an email and then we can talk. All right. So what is the melting temperature? So if you look at the graph up here, remember melting is where we go from a solid to a liquid. So our melting temperature on the graph, where we go from solid to liquid, is this point right here. Okay, so that is, if you follow it over to the y-axis, that is at 20 degrees. 20, I have to do this with my mouse, it's terrible. Now, the melting point and the freezing point are the same thing, because if you melt an ice cube, it melts when it's basically at 0, and when you have liquid, it freezes at 0. So the melting point and the freezing point are the same, and that's a big thing that you need to know. All right, boiling point. So that's the other plateau. Boiling point is we go from a liquid to a gas. So that's right here on the graph. And if I follow that over to my y-axis, that's at 60 degrees. It is a little blurry, I'm sorry, but it's 60 degrees. And I apologize for the dog barking in the background. All right, and then just like the melting and freezing temperature are the same, the boiling and condensing are going to be the same too. So those are both at 60. Okay. It says which section of the graph is it a mixture, or sorry, in which section of the graph is the temperature of the gas decreasing? So we are a gas from A to B, So the temperature of the gas is decreasing from A to B. If you look here where the plateau is, the temperature doesn't change. So when we're going from gas to liquid, the temperature doesn't change. But here on the diagonal, from A to B, our temperature is decreasing. So I'm just going to write A to, this is so hard to do with a mouse, B. All right, next it says, in which section of the graph is the substance a mixture of liquid and gas? So liquid and gas. So liquid's here, gas is here. So from B to C on the graph, notice that we're a mixture of both. So from B to C. There you go. So for today, it's just a quiz. Mr. Zorn, if this is about your stapler, I'll find a way to buy. I don't need a new stapler. Actually, you know what? At home, I have this little crappy stapler. Okay, so there you go. And you're far away, and we're under quarantine, so there's no way you can get a hold of my stapler and break it. So I'm just going to put this somewhere safe where you can't get to it. Okay. So for today, all you had to do is jump through that quiz. And again, the quiz is, if you go to my website, if you go to my website and you click on the e-learning button, and then you click on chemistry, or if you're going through hack, you can click on the link for today. It'll bring you to the same page. So just relax. Just relax. Always freaking out about everything. So there's a video that explains what you need to do today. And then if you look down here, there's directions. So there's a screencast where I basically just went through everything that I just talked about right now. You can take guided notes if you really want to. And then there's a link here for the quiz. Okay. Now here's the thing with the quiz. Before you panic, you can take the quiz as many times as you want. Okay. You can take the quiz as many times as you want. I'm only going to put the score in if it has a positive impact on your grade. All right. So I'm trying to help you guys out. We're trying to take advantage of this time. So I'm only going to put the score in if it has a positive impact on your grade. All right. If it doesn't help your grade, I'm not going to put it in. Okay, so this is an opportunity for those of you that need the extra points to take advantage of that. So what questions do you guys have for me? Anything? What are we doing over spring break? Anybody do anything fun over spring break? While you're typing in the chat, I haven't done the stuff from before spring break. We'll talk about that. You jumped in late. This is why you and I need to talk. Just want to remind you that tomorrow is Crazy Hair Day. All right, I'm not sure what I'm going to do for that, but tomorrow is Crazy Hair Day. So if you take a selfie with your crazy hair, post it on Twitter and then tag me at Zorn Science so I can see your crazy hair. That would be fantastic. And then you should have gotten an email with the rest of the Spirit Days. I'm going to do my best to try and participate in each day. Today was Superhero Day, and you guys are my superhero because you're making this e-learning happen. All right, it's not just us. You guys are doing it too. So I appreciate those of you that jumped in to join me today. So that's it. That's all I had for you guys today. If you don't have any other questions or if you don't want to share what you did over spring break, I will sign off. And Cecilia, check your email in just a minute. I'm going to shoot you an email so we can catch up on your situation. All right. If you guys don't have anything, I will see you guys tomorrow. Have a good rest of your day. And don't forget, tomorrow is